Hello, hello! Developing the MetaInsights API, an AI-powered system that assists doctors by processing and analyzing complex medical cases, requires a robust, scalable, and performant framework. Today we will compare Flask, FastAPI, and Django alongside their supporting servers to determine the best tools for this project. Let's dive into the strengths, trade-offs, and ideal use cases for each framework, keeping in mind the MetaInsights requirements. But in your case, when you are developing your project, you have to keep in mind your requirements and important use cases when you are choosing a framework. Before diving into the comparison, it's important to define the primary requirements. Performance and scalability. Efficiently handle concurrent requests for querying and processing. API-first design, easy to be traceful and possibly GraphQL APIs. Integration with AI ML tools. Compatibility with AI libraries like PyTorch or TensorFlow. Asynchronous operations. Support for sync await, the same we have in JavaScript, for high concurrency, querying databases like Qdent. Ease of development, developer productivity, and maintainability. Let's start with Flask. Flask is a lightweight and opinionated framework, making it a popular choice for small to medium projects. It's simple, minimum boilerplate, you control the application structure. It's flexible, add only the features you need via extensions like Flask RESTful or Flask SQL Chemi. It is microservice friendly, ideal for building small standalone microservices. It has a large, mature ecosystem with many plugins, but it has trade-offs. No async support, Flask is inherently synchronous. Async support requires workarounds like Qdance or ISGI wrappers. Flask itself is not API first by design, but you can build an API first system with it by adapting the right tools, practices, and extensions. If API first design is a primary requirement for your project and you want a framework that naturally supports this methodology, consider using a framework like FastAPI or Django REST framework. However, Flask remains a powerful and flexible choice for custom implementations. Flask is not inherently AI focused, but its flexibility and compatibility with Python's ML ecosystem makes it an excellent framework for building and serving AI-powered applications. For larger, more complex ML systems or higher performance needs, you may consider alternatives like FastAPI or dedicated model saving solutions. For high concurrency, Flask requires additional configuration, tagging with Gunicorn. Developers need to write or integrate additional code for features like validation, serialization, or open API docs. Best servers for Flask, Gunicorn, the standard WSGI server for Flask, reliable but limited to synchronous tasks. Other servers, Uvicorn or Hypercorn, but if the Flask is modified for asynchronous tasks. Flask framework is considered for small to medium-sized projects, APIs, without heavy concurrency requirement. Let's continue with FastAPI. FastAPI is a modern framework optimized for building high-performance APIs with asynchronous capabilities out of the box. Built on ASGI via Starlet, making it faster than Flask for concurrent tasks. FastAPI utilizes Python's type hints for request validation and data serialization. It generates interactive Swagger and TreeDoc API documentation automatically, asynchronous by default, ideal for integrating with AI systems requiring long-running tasks. It's scalable, it handles WebSockets, long pooling, and other real-time features effortlessly. FastAPI is designed to support API-first design principles, making it an excellent framework for developing modern APIs. Let's talk about trade-offs a little bit. The learning curve is a little bit bigger, requires familiarity with async await and type hints. Smaller ecosystem compared to Flask or Django, but rapidly growing. Although simple, requires some setup for databases or complex middleware. It's more configuration. Now let's talk about best servers for FastAPI. Uvicorn, Hypercorn, Gunicorn. The default server for FastAPI is Uvicorn, lightweight and fast. Hypercorn offers HTTP3 and quick support protocols. That is actually something very unique and good, though slightly less popular. Gunicorn with Uvicorn workers combines Gunicorn's robustness with Uvicorn async capabilities. FastAPI is ideal for API-first projects, application needing high concurrency, or real-time features, probably AI/ML powered systems. Let's move to the next famous framework, Django. Django is a full-stack framework designed for rapid development and scalability. It's all-in-one framework, includes ORM, admin panel, authentication, and more out of the box. Thousands of plugins and a massive community, meaning mature ecosystem. Saving time with features like the Django admin, the built-in user management. That means rapid development. Proven in large-scale applications, modern Django supports Async, enabling real-time applications. Let's talk about some of the trade-offs of Django. Heavier framework, more overhead compared to Flask or FastAPI. Steeper learning curve, requires understanding Django's conventions and components. Async limitations. Although it supports async, Django ecosystem is still transitioning, with some plugins lacking async compatibility. Can Django be used as API-first design? The answer is yes. Django can be effectively used for API-first design, but with certain considerations and trade-offs. Is Django suitable for working with AI/ML tools? Yes, Django can be effectively used with AI/ML tools to create applications that integrate machine learning models and AI-driven functionality. While Django is not specifically designed for AI/ML workflows, its versatility and robust framework make it a solid choice for building web applications that leverage AI/ML models. Which servers are best to use for Django? Gunicorn, Daphne, Uvicorn. Gunicorn is traditional for WSGI apps. Daphne is best for async Django apps, required WebSocket support. Uvicorn is a fast alternative for async Django. Django is used mostly for large monolithic applications with complex business logic or APIs required extensive built-in features. In our next video we will discuss servers.